Alright guys, we're gonna go live and start with this session today. I'm just gonna wait for a few more people to join and then we'll kick this off. So just bear with me a second while I just quickly share this to my Twitter feed, etc. And then we'll get started. Looking to get into security. Just turn that down a little bit. Alright, cool. And hi Jamal, hi Mark, thanks for tuning in. Let's kick this off in a little minute. Just give it a few more minutes for others to join. For those that join, they can obviously catch up on the catch up once the video is being published after this live session. No problem, Jamal. Thank you. These videos help me. Hopefully inspire you guys, help you in learning, but also as well keep me going as well. So it's quite good. Alright, cool. So I think we're going to make a start, and for those that join in late, they can obviously watch the replay back once it's published. Feel free to share the link out on Twitter, Instagram, Facebook, whatever social media platforms you're using, to those that you may think will find this relevant and useful. Just before I start, shout out to Dewan, Lab Everyday, all the Lab Everyday community. We published a video last week, in fact a week ago today. Go check that out on Dewan's website, all about what it's like to be a network engineer, etc. Alright, cool. So this session today is focusing on DMZs. You know, what is a DMZ or a DMZ? I was requested by a member of the Lab Everyday community to try and put something together, just to give him a little bit more of an idea as to what a DMZ is and how you can actually configure one on a Cisco ASA. So I thought it'd be quite useful to put together this session, because I know there's quite a few people within the Lab Everyday community that are starting on the CCNA security or looking to get into the security aspect of it. So I thought it'd be useful to put this together. So let's jump straight in. So DMZ, so it's the abbreviation of a demilitarized zone, and what it basically does is it separates the LAN or the local area network from untrusted and semi-untrusted zones. It's often used to host external facing servers, so basically servers that people that are coming in from the internet need access to, such as web servers, FTP or proxy servers, and also servers that, you know, internal clients or internal employers might need access to as well. So it's kind of like a zone on the border, if you like, between your inside and your outside network. Typically there's two design architectures of a DMZ. One with a firewall with 3 or more interfaces. This is what we're going to focus on today because it's relatively simple, especially those that are not really familiar with ASAs, etc. I didn't want to dive too far into doing more complex networks, so we'll stick with this one. You typically normally see one firewall with 3 interfaces with different zones when you're either working with small customers that don't have a large budget, and not necessarily medium customers, but you might see that. But the chances are moving medium to large organizations, you start to see the organizations deploying things like clusters or active standby failovers, firewalls, etc. So typically more seen in a smaller environment or a branch office. Two firewalls separating the internal DMZ and the internet is the other architecture. Now that's the one that we're just briefly touching on there, which you tend to see in larger organizations, and we'll take a look briefly into them in a minute. But for those that are actually more that are interested on more about the architecture and designing DMZs, I've got some references here. I'll share this presentation after this knowledge transfer, but we've got a Cisco Safe Reference Guide. I'll show you that in a minute. And we also have Cisco VDs, which is Cisco Validated Designs. So we can have a look on there. That's got a good breakdown of information of how each segment of a network should look and what should be included in considerations, etc. So just before we jump into the configurations, what we'll do is we'll quickly take a look a little bit more at the Safe Reference Guide quickly, just to kind of show you what it is. So this reference guide, as I say, it's available on the Cisco website. I'll share this presentation afterwards. So basically you've got different sections of the network, if you like, and where a DMZ typically sits will be within the enterprise internet edge. So if we just scroll down here, and hopefully you can see that this is typically what you'd see here on an enterprise network, as I was speaking about before. So I'll just get my pen out, and what you can see here, just give me a second, turn my pen on. Yeah, so what you can see here is you've got, within the corporate access DMZ, you've got things like your web server, DNS server, you've got your email security appliance, and then with the enterprise environment, you've got what it looks like two firewalls here, and this is separating your internal infrastructure, which is here, and then you've got obviously your service provider edge, which goes out to the internet, etc. So this is typically like I said before, this is this block here. This is the middle zone between the internal infrastructure and the external infrastructure. So if we scroll down, I mean this is very useful. So I do recommend you check this out, because it's got things like key threats, guidelines for designing, your corporate access DMZ, and so on. It just continues all the way down. So it's definitely worth checking out this website. So what we're going to do, as I said earlier on, is we're going to focus on the one firewall with 3 or more interfaces, and this is just purely to give those that are new to the security space an idea of how you can configure a DMZ on an ASA. So if we go down to the configurations and steps, I've put some tasks here that we're going to work on today, that we're going to do. So we're going to start off by configuring interfaces with an IP address. We're going to configure names we're going to configure Icmp inspection, and you'll see why later on. And then we're going to configure ACLs for access to and from the DMZ, and we're going to test access to and from the DMZ. There's also one more step that I haven't put in there, which is configuring NAT for outside to inside access, but we'll cover that anyway. So if we go back to this, what I'll do is we'll open up our lab. So what we have here, again, might just be worth pointing out, is here. So that's pretty much the three interfaces, as you could probably see. Let me just make that a little bit smaller. So again, DMZ here, we've got the outside network and we've got the inside network here. So this is the ASA. We've got three interfaces. We've got the inside, the DMZ, and the outside. From the address space, we're looking at here 209.209.209.0. This is the outside interface network subnet, if you like, and then we've got a separate subnet for the DMZ and likewise for the inside network. So let's kick this off and we'll jump in with the configurations. And for those that have got any questions, don't worry, I'll plan on answering those questions at the end once we've done this lab. Let's just delete that. So this is a fresh lab. We'll start off by configuring the IP addresses for the in user, the server, and the out user. So we'll start off with the in user, and these are VPCs, by the way. So we're only going to be testing access from the so basically we're going to be testing access from the let me just get that pen up, make more sense. So from this user, we're going to test access to the server in the DMZ here, and then we're going to test access from the DMZ to the inside network and the outside network, and then we're going to test access from this outside client going to the server, and we'll see the difference in behavior with each one of those scenarios. So we'll configure the IP address now for the inside user, and we're going to use 10.0.0.0.10/24 network, and the default gateway will be 10.0.0.1. If I just do show, yep, so we can see that that's set now. There's no point pinging yet because nothing's configured on the ASA. So we'll go across to the server, we'll do the same. 172.16.0.0, 05, and that's a /24. The gateway is 172.16.0.1. And if I just do a show again, confirm that that's correct, and then we'll move to the outside user and we'll configure an IP address of 209.209.209.2. Subnet mask is the /30, so it's 255.255.255.252, and the gateway is gonna be 209.209.209.1. I'll just do a show on that again. Okay, cool. So that's all our end hosts configured. So server, outside user, and inside user configured. So now the main focus is to focus on the ASA now. So let's just go back quickly to the steps. So now we're going to configure the interfaces with IP addresses. Okay, so all this work now, all these tasks are going to be on the ASA. Alright, cool. So it's a blank ASA, as you can see. We're just going to start by configuring the interfaces. So we'll start with gigabit 00 going to in user. So that is interface gigabit 00. IP address of 10.0.0.1/24. And with the ASA, if you now issue a, in fact, let's do it. If you issue a no shutdown, you've configured the IP address, you've issued a no shutdown, but you still won't be able to ping. So let's just try this. So ping 10.0.0.10, and the success rate is 0. Now the reason for this is you need to configure names on the interfaces. So as I said earlier, if you didn't know what the name ifs were, or the names on the interfaces, this is quite important for the ASA, because it's referencing different zones, if you like. So what I'll do now is I'll do a name if, and then we're going to name this one inside. And as you can see, what the ASA has done here is it's give it a default security level of 100 because we've named it inside. Now the ASA knows that if we name it inside, that this is a trusted network. So by default, it gives it a value of, it gives that interface a value of 100. So the interface value goes from 0 to 100. An IA interface can connect to a lower level security level interface, but a lower security level interface cannot connect to a higher security level interface without specific ACLs in place. So again, a higher level security interface can connect to a lower security level interface, but a lower level security interface cannot connect to a higher level security interface without ACLs. So now that that's done, let's just see if we can ping again. So I'll just do up arrow, probably makes it quicker. And there you go. So now we can ping, as you can see. So we know that that's working now. And if we do it from in user to ASA, will that work? So if we do ping 10.0.0.1, and there you go. So we can ping there as well. So we know that we've got internet interconnectivity between the in user and the ASA. So let's do the same quickly for the server interface, which is our DMZ, and also for the outside interface. So I do interface gigabit 03. IP address 172.16.0.1/24. Name if, we're going to call this DMZ or DMZ. And as you'll see, once I press enter, it's going to assign it a security level of 0 because it doesn't recognize the name. So as you can see there, the security level 0. To change that security level, we'll just do security level, and we're going to change this because it's a semi-trusted zone. So because we want to, because we partially trust it, because in essence we're going to have services within the DMZ that internal users will be accessing as well. We're going to set this level to 50 in our case. So we're not giving it from this server. Let's try and ping our gateway now. So we're going to ping 172.16.0.1, and that's successful, so that's nice. And we won't ping the other way because we know that that should be working anywhere. So we'll configure the outside interface now. IP address 209.209.209, and this is kind of simulating a public network. So as you can see that we're using a non-routable address, public address. So we're using 209.209.209.1, and it's a /30, so it's a 252. We're going to give this a name if it's outside, down for that. And now let's see if this outside user can actually ping the ASA. 209.209.209.1. And then we go, because we can ping it because we're directly connecting. Alright, cool. So that's the interfaces configured. Let's quickly fly back to our presentation, and we've also configured the names for each interface. And let's just do a quick show name if, and then you can see that we've got inside, outside, DMZ. You can see that our inside has got a security level of 100, so we fully trust this. We've got the outside, which has got a security level of 0. You know, we don't trust the outside network. And then we also have our DMZ, which has got a security level of 50. So we partially trust that. So now we've done that, we've configured security levels for each interface. I've explained that, and hopefully that makes sense to those that are watching. We need to configure Icmp inspection, and you're going to see why now. So if I want to, so as I explained earlier on, in fact we'll do each use case now. So what we're going to do is we're going to try and ping from this user to this server, okay, and we'll see if this works. And this is where the concept of security levels kind of comes in to effect. So if I try and go to the in user and I ping that server at 172.16.0.5, we can see that this is failing. So the reason that this is failing is because by default Icmp inspection is not enabled on the ASA firewall. You need to enable Icmp inspection before you're allowed to pass Icmp traffic. So we'll do that first, and then we'll test this use case again. We'll see if we can ping from the in user to the server. So to actually troubleshoot that as well, we could have login enabled. Right now it's disabled by default. What we'll do now is I'll do login buffered, and we'll just do debugging. So we get all the logs, and we'll enable login. So let's do show login. Right, okay, so it should start putting output now. It should start showing us output now. So again, before I enable Icmp inspection, let's just try and ping the server again. And let's see if the ASA gives us any output, which it does. Okay, cool. So don't be kind of put off by looking at this if this is the first time you're looking at the login information. You know, you do kind of get used to it. So what we can see here is that there's been a connection denied from, where was we pinging the right way? Oh yeah, yep. Source DMZ, yeah, inside. So 0 to 0, deny, inbound Icmp, source, for address, yeah, that's right. Because yeah, Icmp inspection isn't enabled. So what we'll do now is we'll enable Icmp inspection, and where it, so if I just do a show run, and I'll show you where it normally goes. So we have the concept of policy maps and class maps. I'm not going to touch on those today because the main purpose of this is just to kind of show you guys what a DMZ is and how it can be configured on an ASA. But yeah, we have a concept of policy maps and class maps. So we've got a policy map here. This is a default policy map on the ASA called global policy. And then within that policy map, we've got a class map called inspection default. So these are all default. So these are inspection parameters that are enabled by default. As you can see, we haven't got no Icmp here, so we need to enable Icmp. So I'm just gonna, instead of typing it all out, I'm gonna quickly do that. and what we need to do, inspect. And if you question mark, you can see all the different things you can inspect. So we can inspect Icmp. We'll exit out of there, exit again, and if I just do a show run, begin policy, and then if we look here now, we can see at the bottom there now we have Icmp inspection enabled. So if I try and ping now from the in user to the server, let's see if it works, and boom, because Icmp inspection is enabled, it now works. So if I do a show login, again, don't really want to go into details about this, but we've got basically different codes within Icmp. In fact, it might be worth showing you quickly. Icmp codes. We just remove that off the screen for now. And if we look at these codes, we had on ours, we had type 8, code 0. So this is saying we're allowing, I'll just agree to that. So 0, echo reply, and an echo. So basically sending echo request and reply. And as you can see here, there's different Icmp types here. And yeah, there we go. So there's quite a few different things if you're interested in looking that up. Alright, cool. So now we know we can ping from the internal user to the server. But did you realize that we didn't have to configure any ACLs on the ASA? No, we didn't. So if I just do a show run access list, it returns nothing because we ain't got no access list configured. So as I said earlier, with the show name if, with the concept of security levels, this has enabled our trusted zone the ability to connect or ping. It won't be able to ping outside because we need to NAT, but it's given us the ability to connect to a different zone, if you like, because this is going from a higher security level to the DMZ, which is 50, and that's a lower security level. So if we try to do that the other way around, so if we try go from, let's get the pen out again. So if we try go from the server to the in user this time, instead of that way, let's see what happens. Will it be allowed? Do you guys think it'll be allowed? Let me know. But we're going to try this right now. So we'll go to the server. And we're going to ping the internal user on 10.0.0.10. And as we can see, it's timing out. So why is it timing out? Well, let's have a look at the logs on the ASA. So we can see here on the logs, we've actually got deny logs. So it's denying inbound Icmp from source 172.16.0.5, which is in the DMZ, and that's our server. Going to the inside network 10.0.0.10. So it's not allowing this connection. And the reason being is because of the concept of the security levels. So if you recall, the security level for the DMZ is 50, and we're going to a higher security level on inside of 100. So this isn't going to be permitted without an access list. So what we need to do is we need to create an access list, and we'll do that now. So we'll do access list. We'll call it DMZ extended permit. We're going to permit Icmp, and we're going to, in fact, let's just do source IP. I'm going to create, let's create objects, because we're going to need objects for NAT anyway. So what we'll do is we'll create an object group, object networks, sorry. Now there's a concept on the ASA of object networks, object network services, and object groups. I'm not going to kind of get into that in too much detail today, but hopefully you understand basically what's going on with the object networks. So basically I'm going to create an object network, and we're going to call this server, and within this we can specify either the subnet, a range, or a host. So we're just going to specify the host, because it's the other thing I'm interested at the moment is the only thing I'm interested in at the moment is the server. So we'll do host 172.16.0.5. We don't need to specify a subnet mask, and we'll exit out of there. We'll create another one, and we'll call this one in user host 10.0.0.10. and while we're here we might as well do the same for the outside user. Object network out user host 209.209.209.2. Alright, cool. So if I just do show run object, we've got now 3 object networks, one for the server, one for the internal user, and one for the outside user. So now let's create that access list that we were talking about that's going to permit us access from the server to the in user. So we'll do access list DMZ extended permit object. No, we're going to permit Icmp object. So we're going to reference the object now. So we need to reference a server. So server, go into object in user. Alright, cool. So show run access list. Now before this access list can work, we also need to configure an access group. So I'll show you this now. So we still won't be able to ping from the server to the in user. Even though we've got a rule in place, it's just not going to happen until we create the access group. So if I just do show login again, we can see the flow is still getting denied. So we need to create the access group. So access group, in fact let's question mark it, does it show us? Yep, so you got access lists and access groups. Once you create an access list, if there's not an access group already assigned, then you need to create one. So we're going to call this one DMZ, and it's for traffic going into the firewall, so we'll do in, and the interface it's going to touch is the DMZ. So access group DMZ, in interface DMZ. So for those that are actually looking at this for the first time or not really familiar with ASAs yet, it might look a little bit confusing, but don't worry. One thing that I would say is, for those that are embarking on the CCNA security, this focuses, well, yeah, it only focuses on the on using ASDM. Pretty much, you don't really do anything on the command line to do with an ASA because it's not required at that level. However, one thing that I would say is that the sooner you get better at using the CLI for the ASA rather than ASDM, the easier your life will be, especially if you're already in the industry working with ASAs. You know, you're not going to be able to jump on ASDM every 2 minutes to configure the things you need. And also, not everything is available configuration wise on the ASDM. So yeah, the sooner you can kind of understand and get your head around the CLI, the better. Alright, cool. So we've done show run access group. So we've got the access group. If we do a show access list, we've got the access list here. We haven't got no hits on the access list yet, but this is about to change. So hopefully we should now be able to ping from the server to the end user. And there we go. So that works now. So we're good. So as you can see from the server, which is sat in the DMZ with a security level of 50, trying to get to a higher security level, which is the inside interface, it's not permitted without an access list. However, from the inside, where the security level is 100, going to the DMZ, where the security level is 50, it's automatically permitted. We don't need any access list for that. So if we just show that access list again, we should see hit counts on that. And there you go. So we see 5 hits now on that ACL. Alright, cool. So we've now got access from the DMZ to the internal network. And the reason I'm showing you this is because this is a really simplified topology for those that are actually just getting into the security, as I said at the start. But if you think of it like this, the DMZ is a semi-trusted zone. There's going to be services in the DMZ, either that be a web server, NTP server, whatever server, that need to communicate or initiate sessions to parts of the internal infrastructure within an organization. So the reason you would then create access lists to permit certain services to the inside network is for that reason alone. Obviously, in this topology, I'm only using Icmp. You wouldn't be really permitting that from the DMZ into your inside network. You would be locking down your ACLs and making them as specific as possible. Because, as I said, the DMZ is a semi-trusted environment where users from the outside can access services within the DMZ, given that the permissions are there on the firewall. Okay, cool. So I hope that makes sense. So now we've got access from the server to the inside, and we know that we can get from the inside to the server. Let's see now if we can get from the inside to the outside. Let's see if that works. So if we try and ping now 209.209.209.2, you can see that this is working. So if we just do a short login, we can see that that's been permitted to a directly connected network. Let's try and do it from the server in the DMZ to the outside, and we can see that this is not permitted. So again, excuse me, what we'll do is we'll create a access list. So we'll do access list. In fact, let me just do no. We'll do access list DMZ extended permit ICMP from server going to out user. And now let's see if this works. So if we try again from the server, there we go. So we've got access now to the directly connected network. So we can ping from the server to the outside, which is directly connected to the ASA. Now let's try and see if we can, from the outside user, get to the server, because as I said earlier, we're going to be having, we'll have services within the DMZ that outside users need to access. So in our case, again, like I said, it's a really simplified topology. We're just going to try and see if we can access by default and then create the necessary rules to ensure that we can access. So let's try from the outside user, ping 172.16.0.5, and this is permitted as expected. So if we just do a show login, we can see that we got a lot of deny statements here. So we're denying the inbound from 209.209.209.2 going to the DMZ on 172.16.0.1. So let's create an access list for it. So we'll do access list, and we're going to call this one outside purely because it's on the outside interface, and going to server access group. We'll call this one outside in, so it's for the traffic coming in to the interface outside. Now let's see if we can ping. Alright, cool. So now we can ping, but in reality, for devices that are on the outside network, we wouldn't want them pinging our direct IP address anywhere. And if they're coming from a public network, it's not even going to work anyway. So what we'd ideally have to do is we'd need to have NAT in place. Okay, so what we're going to do now is we're going to create a NAT statement that will effectively not allow this outside user the ability to ping the direct real IP address of our server, because really we want to hide that. We don't want the whole world knowing our real IP addresses inside. So what we'll do is we'll just quickly go back to the ASA, and we've got two. Again, I'm not going to touch too much on this because I just wanted to kind of do this session today to show you how you can actually configure DMZs on an ASA, i.e. the interfaces, security levels, etc. So this is considered a little bit extra, but we have the concept of NAT, which I'm sure most of you are familiar with. So we have the ability to mask real IP addresses with other IP addresses, with mapped IP addresses. So with the ASA, we have different ways of doing that. We have network object NAT, which we're going to do today, and we also have something called twice NAT, which I might show you. So what we're going to do is we're going to first start by creating a network object network even, and we're going to call this let's call this server NAT, and we'll give this an IP address of in fact, let's do range, considering more people than one might be. In fact, no, we'll keep it simple. We'll do host, considering that this is just a one-to-one service from the server to the specific outside user. So we'll make up an IP address. So let's do 208.208.208.5 for instance. Let's do that. Alright, cool. Do show run object, and we need to go into the object network server because we're going to apply object NAT on this. So we'll do, in fact, I'll just copy that so it's quicker, and then we'll do NAT, And the concept of NAT is slightly different to standard iOS devices, as you can see here. So we need to NAT, and then we've got brackets. So we specify the interface, so the rail interface, which is in our case DMZ, and then going to the mapped interface of so it's going to be going to outside. So we're going to NAT DMZ to outside, and we'll do a question mark so we can do source. And what we'll do is we'll do static, and then we specify the object. So it says the object or the object group for the rail source. So this is the one that we're actually using. So we'll do server. Now we specify the mapped source. So it'll be the server NAT that we created. And then direction. So this is it's worth saying that this static NAT is unidirectional, so we can initiate sessions then, given that access lists are in place from the outside user in. So we'll do destination static, and this is what we're going to do now is we're going to do something called identity NAT. Don't worry about this because, like I said, this is just a little bit extra. I just really want to get the point across where we can actually change the IP address that the outside users use to access the server. So we're going to use static, and it's going to be, we're going to keep the destination the same. So out user. So if I do show run NAT. So now that's our NAT rule in place. So we're going to NAT from the DMZ going to the outside, and as I said, this is unidirectional given that the correct ACLs are in place. Source static, so it's going to be the rail address, the server address going to, is mapped to the server NAT address, the 208.208.208.5 that we created. And then the destination is going to, we're using identity NAT here. This is staying the same. So this is going to keep basically the same IP address of the outside user. So now if we go back to the outside user and we try and ping the real IP address again, let's see if it works. And as we can see there now, it's not working. And this is good. We don't want it to work. We don't want outside users to be able to access the servers using the real IP addresses. So let's just do a show login. So yeah, we've got some asymmetric. So let me just do show run, show NAT. Yeah, so we ain't got no hits there. Show access list. Show run access list. Outside. Going to the server. Yeah, cool. So that the rules are still in place. So now if we try and ping them from the server, not from the server, from the outside user again, but we try and ping the NATed IP address 208.208.5, we can see now that works. So we can't ping the real IP address, which is good, but we can at least now ping the masked IP address of 208.208.208.5, which is good. So these outside users will never know the real IP address that's being used on the inside on the server. So if we just do show NAT, we can see that we've got translations now and untranslations for that Icmp flow we've just created. If I do show xlate, we can also see that we've got NAT from outside to the DMZ, which is using the, so it's keeping the same address here, whereas we've got the translation, so the source is being translated here. The destination stays the same, but the source is changing from 172.16.05 to 208.208.208.5. Alright, that's cool. So I think that is probably it. So yeah, we've tested, we've configured ACLs. We'll just quickly have a look at those ACLs. Short access list. So we can see that we have from out user to server. So we can see that we've got hits on this. Now with the access list, we still specify, because it's on our ASA, we specify the untranslated address. We don't specify the we specify the translated address, so the real address, rather than the untranslated address. So we still specify 172.16.0.5 rather than 208.208.208, because once it's untranslated, it's not going to match the rules, and it won't be permitted. Okay, cool. So yeah, we configured interfaces with an IP address, pretty straightforward. We configured names for each interface, and I also explained how the names work, the naming conventions, and the security levels, which we did as well. We also did a demonstration on trying to access lower security level to higher and vice versa. We then configured Icmp inspection after we found out that we needed to have it enabled in order for Icmp to work. We then went on to configure ACLs for access to and from the DMZ. And then what we did is we changed the we added NAT so that we could only access a server using the NATed IP rather than the real IP address. And then last but not least, we tested the access to and from the DMZ. So I think that is pretty much it. We've obviously just done the lab, so I'll just turn it over to the questions. I hope everybody's enjoyed that today. Let me just get the questions up. Alright, cool. So let's have a look. Alright, cool. So I'm going to start from the top here. So, Manic Tech Tips, thanks for tuning in. What is the DMZ? When and why should we use it? So, I'm not sure if you tuned in from the start, but basically the DMZ is a demilitarized zone. So it's a semi-trusted zone whereby internal clients can access services within, but also external users can also access services within the zone. So typically you'd get things such as web servers in there that, you know, internal, external users will want to access. So things like this, and yeah, that's pretty much why you use it, to it gives a zone that can be used to share services with trusted clients and non-trusted clients. So I hope that makes sense. Okay, Bruno, thanks for tuning in. What's the difference between enabling Icmp on the ASA interface versus configuring an ACL? So as I showed earlier, let me just go back to this, it might make more sense. So I didn't configure Icmp on the interface, I configured Icmp globally. So let me just do a show run. No, I'll do. Alright, cool. So when I configured Icmp within the class map, I didn't configure it on the interface. This configures it globally. So as the policy map says, this is a default policy, and this configures Icmp. Once I enable Icmp inspection, this configures it globally. So the difference is, as I showed within this topology, was that, just get back to the screen, sorry. There we go. So the difference is, once configured within the global policy map, we then have the ability from higher security level interfaces to ping or communicate with lower level security interfaces. And I showed you that earlier, whereby we did basically from this device here, we could ping the server, but then when a server tried to ping, because this is a security level of 50, this is security level of 100, so this works fine with Icmp inspection enabled, and other communication would also work, but we did Icmp. However, when we tried going this way from the server to the user, this failed. Even though Icmp inspections enabled, it failed, and the reason it failed was because of the security levels. So I hope that makes sense. And that's why you then configure an ACL for anything else that wasn't permitted. So if we add new devices to the DMZ, do they automatically inherit the permissions? So by permissions, I'm not too sure what you mean. Could you elaborate on that? The permissions? Are you talking about the access lists? Alright, cool. So I'll just put that on there. Just give me a second. Okay, cool. So if we're talking about the access list, so if we just do a show run access list. Oops. So I'll do a show run access group. So with the access list, in our case, no. If I added another device to the DMZ, so let's say for instance, let me just get the good old pen out again. So say for instance, I added a switch here, and I put another server hanging off of here. Let's just say server 2. Because so we've got the access group is cool, we're good with the access group now, we don't need to create another access group. But in terms of the actual access lists, we're being specific here. So we're permitting this would have a different IP address, and then we're permitting it to the in user. So again, the thing that's going to need to change for the access list is this section here. So that would need to change before the new device was permitted access. However, we wouldn't need to the access group here. Oops, that one there. Even though I've just drawn over it, we wouldn't need to create another access group because that's already in place now. So it'd just be purely the access list. I hope that makes sense. and that would also be the same for the NAT as well. Yeah, that's right. So if I was to configure, so the question there was, okay, so is it because ACLs have been configured based on the host IPs and not the network? That's correct. So if I were to configure an ACL that permits that IP address, the 172.16.0.0, and then we placed it in here, so we had an object that basically covered that subnet, then it would be permitted. But because you've been because I've been specific in the ACLs, that's why you'd need to create a new ACL. Alright, cool. So again, I hope you guys have enjoyed that and found that useful today. If there's any more questions, feel free to drop me a comment in the description. But yeah, if there's no more, thanks for watching, and look out for my next up and coming videos. But until then, see you later.